Okay, so I'm going to kind of get you started on this last section, and this is more of a mathematical thing than anything. So we're back to a student hangs 0.125 kilogram mass, sets it into oscillation, returns the following data for position and velocity. So with this one, if you notice what's going to happen, this is measuring this distance, and the initial distance is like 0.5, and then it goes up to 1. So with this one, it's a little bit different, but it's the same idea. Because what they're doing is like they're measuring the distance from the floor. So at the beginning, it's 0.5 meters away from off the bottom of the floor, because it's between like 0.4 and 0.6. Then they're going to let it go, and then it's going to end up at the highest point at 1 meter. Okay? So you're going from 0.5 up to 1 meter. So what that means is that that equilibrium point, okay, is going to be halfway in between 0.5 and 1. What's halfway between 0.5 and 1?
0.6.
How about 0.75? Okay. So if the equilibrium point is halfway in between, what's the value of the amplitude? 0.25, right? So that means that it goes 0.25 meters above the equilibrium point, and it goes 0.25 meters below the equilibrium point. So now I know my amplitude, okay? So you've got a velocity time graph that starts at 0. Why does it start at 0? They pulled it down, right? The stretch, boom, they let go of it. Which direction is it going on the way up? Up. How have they defined the system? Up as being positive, down as being negative. So you'll notice that when do you have that maximum velocity? When it's at the middle, when it's going through that equilibrium point. So you should be able to, at this point, look at how these graphs correlate. You go, oh, okay, right, I've got my maximum velocity when it's going through that equilibrium point. I have my minimum velocity when it's at the extrema, at the top or the bottom. Okay? Cool with this. Now, so at number 20, at any given point in the oscillation, 3 forms of energy could be present. What are the 3 forms? UG, us, KT, okay? So you can have 3 potential forms of energy. Now, when you get down to 21, what they're doing is that they're lumping all of the potential energies into one big value of U. Okay, so they're just saying U is just going to be the sum of all of the potential energy. Okay, we're not going to break them out. We're just going to say it's just going to be U. Okay? So you got the E total equals U plus K. If you're a Jayhawk fan, you could write that as K plus U. Okay?
That'll get you the right.
It could. Okay?
No, it will.
All right. So now let me explain what they're asking for on 21, because it sounds very wordy, but it's really not. So, however, if one knows the maximum velocity, then one can determine the value of K at that point. U will be 0. The equilibrium point can be defined da-da-da-da-da. Okay? Setting E total equal to the maximum kinetic energy, where V equals V max. Write an expression solving for E total for the E total for U, which sounds horribly daunting. Okay? So basically what you want to do is that you want to solve, let's just start with this idea. You want to solve this equation for U. So what do you get? So U is going to equal E total minus K. Start with this idea, right? Don't make it complicated. Start at the beginning. Now, here's the story. But E total could be one of 2 things. It could be either all U, or it could be all K. So, because of the fact that they're talking about setting this equal to V max, right? What are you going to be talking about? The kinetic side of this. So we can set this E total as 1/2 M V max. Hold on. I'm just going to screw that up if I can. 1/2 m v max squared minus k. It's the end of the day. And yeah, at the end of the day, my iceberg is shrunk with 3 different preps. Yeah. Okay, so let me rewrite this 1/2 m v max squared minus k. Okay, and that's going to equal u. Okay, so there's your answer to 21.
That's it?
Okay, there's your answer to 21. Now, to save you a whole bunch of hassle when dealing with some really random trig, you've got that equation that you've seen before, that negative v max sine 2 pi t over t, can use to determine the velocity at any point. Take that equation for kinetic energy, insert the vt function for this velocity. So I'm going to make this simple to save you a bunch of hassle. So on 22, here's what you end up with. All you're going to do is going to take, because this k is 1/2 m v squared, and that's just some of the generic velocity, okay? It could be 0, it could be the max, it could be anything, right? So I'm just going to save you some hassle on some trig. So that's going to be v max, and I'm going to try and write this very nicely, Mara, so you can read it, minus 1/2 m. Now this is where this gets complicated.
Oh, negative v. Yeah, because you're finding the velocity at any point.
Oh my god.
Substituting velocity to that.
Oh, stop. Oh, it's just, you can stop now. It's literally just that.
Okay,
MV
so
squared.
all I did, okay, and this is where this gets wonky. This is 22. Okay?
You just put this in.
So, well, it's actually 22 and 23. Eventually, when we get there. So, this, all we're saying here is that since v equals negative v max sine 2 pi over t, and this is 1/2 mv squared, if you substitute that in, this whole thing right here got substituted in for the velocity function of that. So, and then I squared it. Okay, so all I did was I took that v max sine 2 pi over t and put that in for v squared. Okay, that's all I did. Don't flip out. It's just a substitution. That's all I did. Don't flip out. What you're after is 23. So on 23, it says substitute the equation from 22 into the equation 21 above and factor out any like terms. So what you're after on number 23 is this. So you can factor out a 1/2 m v max squared, and you're left with 1 minus sine 2 pi t over t squared. Okay? So, what you're going to do on 24, this is where you're on your own. You know what the mass is. That's 0.125 kilograms. Okay? You can look at the graph and find your V max. Let me give you a hint. So that we're all doing this the same, use 1.6 meters per second as your V max. So, at time 0, at these different times, you're going to calculate the value of U. Some of these answers are going to be 0. Some of them are going to be around 0.2. So, that's what you have. Then, here's the last part of this. This is all multiple choice questions. Okay? Give these a look. I want to spend a lot of time going over these tomorrow. This is the end of the lab. So, all right. Shut down the camera, please, Mark.
Thanks.